to create a GitHub account for us to be able to. So when you're cloning, doing a Git clone, you're actually bringing a file that exists in your GitHub and cloning it to your own repository. That's what Git clone does. When you're doing a Git pull, you're pulling from your GitHub to your local repository. That's what you're doing. When you're doing a Git push, you're pushing your file from your local repository to the GitHub. Now we saw how to create a Git branch. We're going to do that again. Then we're doing a merge. You can do Git merge when you're merging two files. We'll also see that. So we'll come back to all these commands in a minute, okay? So let's get a little bit into Git branching and merging, right? Let me share this other screen so I can show you a little bit of demonstration. Then we'll talk about that here. So this is a branch. This is what it is. Branching is a branch of a tree. That's where the name comes from in the first place. So this is a branch. The idea is this branch, you have a branch and you want to do something else, you can branch out of these branches, right? And you see this branch has leaves. So you can create a new leaf, then merge a new leaf back into the same branch, okay? So this is the concept of the head, right? So this is when you create, this is a database object that is created once you initialize your Git, right? It has a head, right? And it has a pointer, right? So if you have one commit and you have a commit, let's assume this is a commit, right? And you have another commit. So what happens is this commit right here, which is the second one, has a parent, this is the head, and this head will be pointed to this head on this, right? On this first commit. The first commit that you create has a head, and you create a second commit, right? This head will be pointing, has a pointer. This pointer will be pointing to this head. And you create another commit, and another commit has a head, and the head here will be pointing to this head, and so on and so forth. So that's how they keep track of each other, right? They keep track of each other. And this has the messages that your commit message right here when you're doing a commit. So that's the concept of the head, the blob, and all that. Blob and which one was that one? And the commit, right? So that's exactly what it does when you're making a commit. So that's the explanation right there. It's simple. So what keeps track of what? How do I know that I made a commit? So if you want to get back to that commit, right? If you want to get back, if anything gets wrong here, how do I get back? How does my system know that it should go back to this? So you use this. This is how, under the hood, this is how the system is tracking it whenever you do a commit. It keeps all that information, right? It doesn't have a metadata, but it keeps that information using this head and these unique numbers. Okay, that's how branching, that's how commit works, not branching, okay? So the context of branching, right? Say, this is the context. On a large project, we often work in multiple contexts. You're working on two different colors. For example, you have two schemas variation for the website at the same time, and you're unsure of which you like best. You're also trying to fix a horrible bug. They also have a bug. So there's a bug, and you have color schemas that you want to, but it's proving tough to solve. You need to really hunt around and toggle some code and off to figure it out, right? So how can you do that? You have a branch. What are you supposed to do? And meanwhile, a teammate is also working on it, so adding a new chat widget to present at the next meeting. It's unclear if your company will end up using it. Another coworker is updating the search bar autocomplete. Another developer is doing an experimental radical design overhaul of the entire layout to present next month. Okay, so this is one project. You are collaborating this project with a lot of people, like maybe 4 people or 5 people, right? And you people are working on the same master branch, right? So how is this going to be possible? Everybody is trying to commit into, serve this into this master branch. It's going to be chaotic. It's not feasible because I will be serving my file on top of someone's file. So we'll be stepping on each other. So that's where the concept of branching comes in, right? So branches are an essential part of Git. Think of branches as alternative timelines for a project. They enable us to create separate contexts where we can try new things or even work on multiple ideas. So instead of working on one same branch, which is the master branch, you can create a new branch and start working on that new branch. I think I have a simulation here before we get into the PowerPoint and read the details. So this is the simulation. This is the first commit that you made, right? And you create a second commit on the master branch. Now you want to add a new color schema. Instead of putting it on the master branch, you create a branch, right? Now you have a red color schema. Now another project, someone else is working on a bug fix, and maybe you're the one working on the bug fix. You don't want to work on the bug fix on the same branch, so you create another branch out of the same branch, right? Then you start working on the bug fix to fix the issues that were going on. Now, you want to put up an experimental design. You can also branch out of that bug fix branch to create an experimental design and keep working on the bug fix. This is an experimental design. And you have another commit here, right? So you keep going. Now, on the main branch, you're still working on the blue color scheme, right? You keep going, but you've stopped the color, the new color on red. Maybe your boss says it doesn't look okay, so you stop working right after making this commit. But you keep working on the blue commit, and you have your experimental design going, right? At some point, this is one project. At some point, you want to merge all this project because it becomes one. The bug fix is okay, so the bug fix is fixing everything that you were doing here, and this is your experimental design, right? You don't want to really merge that, right? This is the color that you tried that didn't really work out, right? So, but you want to merge this because you fix all the boxes here, right? Maybe your red schema, you use it in the box fix, and then you want to merge it to the master branch. Then you do a git merge. So this becomes your main master branch now. You merge it to the master, so this becomes the main branch, okay? All right, so that's what branching is all about, okay? Let me switch back to my PowerPoint. Let's do some tutorial now. Okay, so how do you create a branch, right? You create a branch with git branch, then the branch name, okay? So like I showed you yesterday, let's do some hands-on. If you have your environment set up, you can do that with me as well. So for example, I want to create a branch. Let me see how many branches that I have so far. So if I do git branch, by typing git branch and hit enter. So I have 2 branches right now. I have the master branch and I also have my renders branch, right? So I can create another branch here. I can say git branch, and I can call it, let me call it bug fix. This is my bug fix branch, okay? That branch is created. So if I do git branch, that should create that. Let me enlarge this a little bit. Yeah, that creates that bug fix branch for me. So now I have bug fix branch, master branch, and my renders branch. So that's how to create a branch. I'm branching out of the master branch. Right? So that's simple. Okay? So let's keep going. Now, I've created this branch. How do I get to this branch? I'm not working on that branch right now. So how do I get to that branch? So this, you can get back to, if you use a git checkout would take you to that branch, right? There's another command called git switch, but let's do git checkout first, right? So git checkout, I want to get to my bug fix branch that I just created. So I can do git checkout bug fix, right? So now it switches me, you see now, it's pointing now to the bug fix, right? It's switching me to the bug fix branch right now. So I can create a file in this bug fix. So a file, call this windows2.txt, right? I'm creating a new file now in this bug fix, and I can do whatever I want to do. Okay, you can save that, right? Then I can do a git add on that, and I can do a git commit -n, and I can type a new commit again. Okay. Right. So I've committed that file. I'm working on a separate branch now. This is not my master branch. I've separated from my master branch. Right. Now that's git checkout. I can check out to another branch as well. So I do git branch. I can check back to if I want to get back to my master branch, I can do git checkout to my master, right? It takes me back to my master branch. So you can move from one branch to the other. If you want to work on the bug fix branch, you can work on the bug fix branch. If you want to get back to my master branch, you can get back and forth. Okay. Alternatively, you can create a branch. You see, we create a branch. When we create a branch, it didn't take us inside that branch, right? But you can create a branch and move into that branch immediately using checkout with that -b option. For example, if you do git checkout -b, right? My windows2, right? Okay, see what it does is it creates this branch and it switches me to that branch, right? I don't need to switch. I didn't need to do a git checkout again to switch. With the -b, it switches me straight into that branch and I can start working on that branch. Okay. Alternatively, we have another command, which is the switch command. The checkout command was the first command. So git build a switch command. Switch command is supposed to be, so with the -b option, you can do that. Create a branch, then move back into that branch. And the same thing with switch, right? We can switch into a branch with a git switch. So let's say this is the branches that we have. Git branch, right? You can do git switch. I can switch to any of these branches. Where am I now? I can switch back to my master branch, right? So git switch does the same thing. It switches you into any branch. So you can use git checkout or git switch. And with git switch as well, with the -c option, right, you can create a new branch and switch into it. For example, you have git switch -c, and I want to call this my windows3, right? So it creates that branch and moves me into that branch automatically, right? So now if I do git branch,
can you
go ahead.
So the green color, when you do git branch, the green color is simply the branch you're on.
So when you see a star, when you do a git branch, whatever you see a star, that is the branch that you are in. Okay. In this case, when I did git branch, git switch -c, it created this branch, my windows3, and it switched me automatically to that branch. So when you do git branch, you will see a star. Wherever branch you are, is going to indicate it with a star in front of it. Okay. So I can switch back to this switch.
Just a quick one, please.
Go ahead.
There's sort of a similarity that's between git switch -c and git branch -b. Please clarify, please.
Okay. So these two commands, they do the same thing, right? They do the same thing. Git checkout and git switch, they do the same thing. If you want to use git checkout, you use a -b to create a branch and move into that branch. If you want to use git switch, use a -c to create a branch and move into that branch.
Okay.
Let's do it again. Git checkout -b, right? A, B, C, D, for lack of name, okay? So I've created this branch and I'm moving into that branch. This is me using git checkout -b. I can also use git switch -c A, B, C, D, E. I'm creating this new branch now, and I'm switching into that branch automatically. So B for checkout, C for switch. Right.
Yeah, understood.
Okay.
Thank you.
Yeah. Okay. Let's continue. Let's see what else we have. So you can view branches using the Git branch. Git branch will show you all the branches. And like I said, the active branch will be highlighted with a star, right? So when you do a Git branch, right, you see the active one will be highlighted with a star, which is this one. So the head is pointing to this one, right? Okay, you can also delete branches with a -d option, right? You can delete the branch. If you create a branch, you want to delete the branch, you're done with the branch, you can also delete the branch as well. So you can do, you can use a git branch option, git branch -d. Let's remove A, B, C, D, right? You can also remove branch A, B, C, D, E. So I'll do git branch again. Okay. So git branch -d. Remember, git branch dash, it's not git switch, it's git branch -d option when you want to delete. It's not git checkout, it's not git switch, it's git branch that you use with the -d option that you use to clean up or delete your branch. Okay. So that's branching. Let me get back to my simulation. I may have something else to share there. Okay, in Git, we are always working on a branch. The default branch name is master. So it doesn't do any special or any fancy thing, right? So this is the master branch. You can call it, the question was asked yesterday, difference between master or main. So in 2020, GitHub renamed the default branch from master to main, right? So it was just a renaming. The default Git branch name is still master, though the Git team is exploring the potential to change it, right? So this is the master branch, this master branch. You have the master branch, you can change it to experimental branch. You can switch, right, and make a new commit, experimental branch, then you can merge, right? This is merging, okay? So we'll get into merging in a little while, okay? So that's merging. So let's get into merging. Let me bring back my PowerPoint. So the next topic is merging. And merging branches the fundamental operations in version control system. Right? The purpose is to combine changes from one branch into another while preserving the commit history of both branches. Right? So for you to do a merge, right? If I want to merge a branch with the source branch now is the master branch because of the branch that you're working. Now you have to switch to the destination branch. Destination branch is the other branches that you created of the master branch, right? That's the destination branch. You have to stay on the destination branch to be able to merge to the master. So for example, this is, let me show you. Okay. So I do git branch here. So I have these other branches. Everything is branched from the master. So for me to merge, already I'm in my Windows text. So for me to merge, I would have to do git merge, right? If I were in master, let me switch back to master. Okay. If I'm in master right now and I cannot do a git merge here on master, I have to get to another branch. So git switch. So say I have something in my renders, right? So I'm switching to the renders. Then I can do a git merge here to master, right? And this will merge my renders to master. Okay. So it has merged it now and have two insertions, right? Because I made changes. So the two insertions that I had, meaning I had two commit in my renders, those two commit now merges to my master. Let me see if I have my wonderful simulation. WTF, is that crazy? Head, what is that? Okay. So this is talking about the concept of head, right? The head is simply a pointer that refers to the current location. It's something that I showed you earlier on. It's pointing to, refers to the current location. That's what it is. Now, this is a head. A head is right here. And you see, this head changes. When you create a branch, right, this head changes. It moves to this place, right? This concept is just what is going on inside your system, right? And now you have a master, right? You're about to merge. Before you merge, the head is here, right? So for you to merge, you have to stay here in this branch to be able to merge to your master branch, right? So you have to switch. If you were in this branch, but you want to merge this branch, you have to switch to this branch and it has to stay here to be able to merge, right? That is, so this goes in and this is the concept of head and how the head moves and all that. Yeah, this goes on internally, so it's not, you don't need to know about this. But that's what's going on. We can go through the simulation of how head works and all that. This is the head. Now you have created a branch. Now the head moves to the dark mode. This is so you create another commit, the head keeps moving. All right, now the head is now in the master because you're returning to the master. You switch to the master. Now you're switching back to dark mode, so it has to move. It's just showing you how the head moves. You switch back here because you want to merge it to the master. So you have to stay here to be able to merge. So you have to stay on this branch to be able to merge. So you come back here and you merge it. So this is just a simulation of how the branches work and how you can merge it. So this is the command to create a branch. And this is how you create a branch. This is how you switch to a branch. It gets switch and so on and so forth, right? So that's git switch and git checkout, okay? So we got two concepts. Any question on those two concepts? Git switch, git branch, git checkout, and git switch. Those are the three commands that we've learned today. Git branch, you can use git branch to check if you have branches, right? You can use git branch to create a new branch, right? Git branch, the name of the branch. Then you want to switch into that branch, you can say git switch into the new branch, or you can do git checkout into the new branch. If you want to use git checkout, you can use git checkout to create a new branch, but you need to use an option, a -B for git checkout to create a new branch. You can use a -C for git switch to create a new branch as well. When you create that new branch, it will move you into. So merging branches. So let's take a look at, let's go through it real quick. Branching makes it super easy to work with within self-contained context, but often we want to incorporate changes from one branch into another. So that's when we use git merge, right? If you have changes in a particular branch, you want to merge it to the master branch, you use git merge. The merge command can sometimes confuse students early on. Remember these two merging concepts. We merge branches, not specific commits. We merge branches, not specific commits, right? So the entire branch, when you're merging, is the entire branch that you're merging, not just one commit that you're making. We always merge to the current head branch, right? So merging made easy, right? Git switch to master, then git merge the bug fix. You can merge to the master or you can merge to the other branch, right? Whichever way that you want to merge. So you can merge your entire master branch to the new branch that you created, and you can also merge this branch that you created to the master. It all depends on this. When I did a demonstration, I merged the master. I merged the master to the branch that I created, to the destination branch. So we can do from source to destination. So where is going to be your source? Where is going to be your destination? So you make that determination, right? Because master branch is just, it's not like it has any superpower. It's just a name so that you know that that's the master branch, that's the main branch, right? But it acts like any other new branch that you create. So you can merge the master to the new branch that you create, or you can merge the new branch to the master, whichever. But most convention is you use the master, right? Every other branch is like additional features, and you merge those features to the master, right? So you can do it either way, but it all depends on what you intend to do. How you're writing. If your master is messed up and you create a new branch, and the new branch is better than the master, right? You merge the master to the new branch. Okay, to merge the bug fix branch into master branch, right? You switch to master. Yeah, there's the bug fix branch. You switch to master, right? And then you do the git merge. When you do the git merge, so the head changes. Now you can do the merge. So this is what it really looks like. Remember, branches are just defined by a branch pointer, right? Just by a pointer. We have the concept of pointer in the head that is in the object, the database object of the Git. So this is what it really looks like. Master and bug fix now points to the same commit until they diverge again when you do a merge. So both of them, yeah, the bug fix pointer and the master pointer, now they're looking at one commit. This is the endpoint that you want to merge them. So that's what git merge does. When you do a git merge, then bug fix, which is your new branch, to the master branch. And it's also called a fast forward commit, right? It's called a fast forward. In other words, not all merges are called fast forward. When you have, this is when conflict exists. This is exactly what I needed to show you. Okay, what if we add a commit on a master? This happens all the time. Imagine one of your teammates merged in a new feature or changed to master while you were working on a branch, right? Rather than performing a simple fast forward, Git performs a merge commit. We end up with a new commit on the master branch. Git will prompt you for a message. So rather than performing a simple fast forward, Git performs what is called merge commit. Okay, this is repetition of that one, and this is the show. So it would end up with, basically what it will end up with is a conflict. You have a conflict, right? When that conflict occurs, that's when I wanted to talk to you about, right, about the merge. There's always, if we're working, I cannot simulate a conflict right now because I'm working by myself. If you're collaborating with other people and they do a merge and my head moves, right? So the head will move. For example, if the person is working on the master and the head moves, and by the way, I'm working on a branch and I want to merge into the last commit that the master had, but that head has moved because someone else has committed into it. So when you merge into it, it's going to create a conflict. That conflict is nothing but showing you the two things, the two documents. It will show you the last commit. This is what this person created, and this is what I created on the Buffets branch. This is the new thing here. How do you resolve these two issues? Right? So you can go in, it will give you this arrow showing you, yeah, this is what is in the head, and this is what is in the bug fix. How do you resolve? You can choose to delete. First of all, you have to delete this off so that it clears it. If you want to merge these two, you just can combine these two documents together. Or you made it correct. You want to delete this and leave this, you clear this. Once you clear this, right, off, you can do the merge again, right? You can do the merge again, and that will clear the conflict, right? So this is called the conflict marker. The contents from the branch you're trying to merge from is displayed between this and this, right? Between this and this. That's where the conflict is. So you can choose to delete that, resolve that conflict. Once you resolve that conflict, you can merge again, right? And after merging again, you can delete that branch, whichever branch that you want to delete, and that's it. So this is the simulation part of it. Let's get into my PowerPoint. My PowerPoint has more details. So we've seen how to create the branch, right? We've done that already. We've used Git checkout, Git switch. We've done that. Okay, we've gone through this already. So Git merge is where we stopped, right? It's the same thing, combining changes from one branch into another while preserving the commit history. Now let's talk about that. You are merging, when you do a Git merge, you're preserving the Git history, and there's a reason I'm explaining this. The Git history is maintained. So every point that you made a commit, that history is preserved, right? The difference between the Git preserving that history, even if you have a branch, the difference is you also have what you call a Git rebase. Rebase is a different command. When you are doing a rebase, let's go to, since we already know how to do a merge, let's go to a rebase. Let's just say rebase. So the rebase would not maintain the same history. The rebase would take the branches and put it in the same branch. Let me see if I can demonstrate this. I don't think my simulation has that. So this is your, let's assume this is your main branch, right? And you have different branches here. Okay, let's say you have this branch here. And in your main branch, you have this commit that you made. And you also this is tough to use. Gosh. Okay, sorry. Let's get this here. Okay, so you have another commit right here, right? Then finally, you want to merge this to this. Okay, so when you do a merge, this is what happens. So all this history of the merge that you create right here, they are all preserved, which is the Git merge. When you do a Git rebase would do this, right? We'll take all this commit and merge it into one, right? We'll take this out, take the whole of this out. It will rebase and will give you only one master. So this is a Git rebase. You put your history as one. So the branches, the history that you had on your branches are gone. So Git rebase will keep just one master with all the commit. It would rewrite your history for you. That's Git rebase. That's the difference between Git rebase and git merge. Now I think I have the pros and the cons here. Git commit the merge. After resolving conflict, commit the changes to complete the merge. Okay, pros and cons. It preserves the original commit history of both branches. That's git merge. Simple to understand and use. The cons is may result in a more complex commit history if there are frequent merges. If you have a frequent merges, it depends on how big your project is. It could be complicated, right? So the difference is the pros and cons of rebases. It results in a linear and cleaner commit history. It reduces the number of merge commits. The con is alters commit history, which can use issues if the branches are shared with other people, right? Conflicts may be more challenging to resolve due to linear reapplication of the commit. So if you destroy the entire history, if you want to go back to find out what the issue was, you may have lost all that history. That's the difference between git merge and git rebase, right? And to use a git merge command, you use a git merge, then you merge the destination to the source. The same thing with git rebase. Git rebase, you can do the same thing too. It's just the command that is different. Git rebase, then you have the source. Let's do that, demonstrate that real quick. Let us git branch. By the way, if you want to get more information when you're doing a git branch, you can use a -v option. -v option give you more information about your commit statements, right? And your branches, right? It gives you branches and it gives you more information here. It's just a verbosity, the number of verbosity that you want, right? So you can do like we've done a git. So we're in the master branch right now, which is our source. Now the destination, let's say a destination is my Rundos 3. I don't think I had anything in my Rundos 3. So I can do a rebase on that if I had some commit. Let's switch back to okay, we have my Rundos. Rundos 2. Let's switch back to Rundos 2. Invalid switch. Switch. Invalid reference to run. It's my Rundos 2, sorry. It's my Rundos 2. So now we're in Rundos 2. What do we have in Rundos 2? We have a file called Rundos file.txt. Okay. So maybe I can add something in there. Yeah. Let's save that. So git commit, git add. So I think I can do git. I can combine the add and the commit statement together, right? With it, I think a -a and a -m. Yeah. You can combine both of them. Instead of doing git add and git commit, you can combine both of them. I'll look for that command. I'm not sure it's -a and -m. Then, right, but let's do it the way we've been doing it. Git add, I add that, then git commit, -m, then my message, new commit, enter. This is just a random commit statement that I'm giving, right? So that's been committed. Now, I want to do a rebase now. I want to rebase this, my branch, my Rundos 2 branch, I want to rebase it to the master branch. So I can switch to my master branch now, can do git switch, master. I'm switching to the master now. Then I can do git rebase, my Rundos 2. Okay, now I'm rebasing this. What this does is it's all the commit that I made on my Rundos is going to merge all that, comment and I lost the history, I will not have the history again on the commit that I had earlier on my Windows 2. So all the commit now is merged into my master. So that's how you use a Git rebase. So that's the difference between a Git rebase and a Git merge. Have I done a good job of explaining those two?
Just, can you hear me?
Yeah, I can hear you.
Real world application. Can you give some practical insights where in the life cycle of your project, how complex, how much time has passed, where you recommend rebasing versus merging?
Okay, I think I have, let's see.
Yes.
Choosing between merge and rebase, okay? I have it here for you, brother. Use merge when you're collaborating with others on a shared branch, right? On a shared branch. Because when you're collaborating with people, you want to keep that history. You want to keep that history when you're collaborating with people. A feature or bug fix branch is relatively short, right? When a bug fix branch is small, you have a bug fix branch and it's short. You don't want to keep the history. You just want to fix some problems that resulted from that, what you're writing, the code you're writing. You just want to do a small bug fix and merge it to the branch. Then you can do a merge, right? So that you keep that history because you have a bug fix. When a commit history clarity is low priority as well, right? You can also do that. Now, when do you use a rebase? Working on a feature branch that you want to appear as a linear sequence. Let me see, let me mute someone.
Yes.
So we're working on a feature branch that you want to appear as a linear sequence. So you make a choice. Do you want to keep the history as a linear sequence? If I'm developing a software, right, I want to keep every branch history, I want to keep it. Because if something goes wrong, I want to trace back to not only where the commit is, right? And I want to, with the commit, I can also know who made that error, so I can alert the person that, yeah, to go back and refactor his or her codes, right? Because I want to keep the entire history. But if I'm doing documentation, right?
But question, who's merging? Isn't it the developers? Everybody's working off of a shared drive, right? And they all merge onto not the Git on their computer, but on the online shared Git. So are you the one merging or are they the ones merging?
They're the one merging. You are the one merging. Now you're merging. We've not gone into GitHub, right? You merge, everything that you're doing is going into because
the repository, the online repository.
The repository. Now, when you do a merge, it's going into the online repository, yes, because you're collaborating in this case, right? Right, you're collaborating on the branch, the master branch. So you're branching out of that master branch and creating your own. And when you create your own, you merge into the master branch, right? So when you're working, when you want to keep a linear clean, for example, if you're working in a government or just writing a documentation and you create a branch to create other things, you want to keep just a linear, you want to do a Git rebase, right? Cleaning up your local branch before pushing it to a shared repository, right? And if you have a branches, your local branch also, and you want to share it, finally share it, right? You can also use a Git rebase, right? It helps for clarity of your history, right? If that's your higher priority, then you can use a Git rebase. So those are some of the when shall I use and when shall I not use Git mesh and Git. It all depends. It boils down to you or what your team wants to see. So you make that decision. So this gets into explanation on how you resolve the conflicts, right? So what I showed you in the demo, that little demo, is the same thing. The details are here, how to remove it, how to resolve that conflict. After resolving the conflict, remove the conflict lines, right? And ensure the files reflect the desired changes. After you do that, you can do a git add again, right? Do a git add. You can specify the file name. You can do a git add specifies dot, which is your current working directory, and you can do git merge dash continue, right? Continue. Then that should merge it, and you do a git commit. Put your number, put your message, and that should do that. Do a git status to verify that it's been merged. Right. So that's how to resolve that the conflict. Git mesh conflict, Git mesh conflict. I am not able to simulate a conflict that we can clean up. But basically is a comparison. What do I have in this code? Two people are writing codes, right? This is the first one from the here. So what do I want to select and add? What do I need my final documents or file or codes to be? Once you do that, clean up this, take this out, take this out, take this out on the file, right? And save your file again and add it again, do a commit statement again, and that resolves the issue whenever you run into that conflict, okay? So that's resolving conflict. So the next thing that we will talk about, that will be in the next class. I want us to get into Git. Before we do cloning, we need to do GitHub. We need to be able to register an account with GitHub. Let me see if we can do that real quick. Introduction to GitHub, overview of GitHub. So GitHub is a web-based platform that provides version control and collaborative features for software development. It is widely used for hosting and managing Git repositories, right? So that's what GitHub is. It is online, it's in the cloud. It is a web-based. It's like Git, but it's a web-based. It's you use Git to connect with GitHub. There are some people that work off GitHub just by GitHub alone. They don't use Git because they just want to store information in GitHub and retrieve information. If you're writing a documentation, like a literature, or you're writing maybe a book, you just go to Git because all you do is write the information, copy and paste, and you retrieve the information. You're not doing anything programmable. So that's fine. So some people that it does that. So GitHub hosts Git repositories, providing a centralized location for code storage. Multiple developers can work on a project simultaneously. GitHub, it's for version control, allowing developers to track changes. Developers can propose changes by creating pull requests. That's what I showed you. You can branch. GitHub supports branching, allowing developers to work on features and bug fixes. Issues and bug tracking. Users can create issues to report bugs, frequent request features, or discuss improvements. Milestones help organize and track progress by grouping related issues. There's something called wikis. So GitHub provides wikis for documentation. There's what is called Git Action. Git Action is like a CI/CD pipeline. You have to write a program to use it. It's a different ball game. It's like Jenkins. It's like a CI/CD pipeline that you have to create. I have not studied Git Action, but a lot of companies are. It's actually relatively new. Some companies are reverting to Git Actions. Some are using GitLab. Some are using Jenkins, right? So it's like a CI/CD pipeline. Right? I don't know how to use Git Action. I haven't even studied it yet. Yeah. But that's one of the functions of GitHub.